Hello everyone, we have a problem from the chapter waves. Three traveling waves are superimposed. The equations of the waves are y1 equal to a naught sine kx minus omega t, y2 equal to 3 root 2 a naught sine kx minus omega t plus phi, and y3 is 4 a naught cos kx minus omega t. We have to find the value of phi, where phi lies in between 0 and pi by 2 if the phase difference between the resultant wave and the first wave is pi by 4. So third wave we can write in terms of sine as 4 a naught sine kx minus omega t plus pi by 2. And this problem becomes very easy if we treat the three waves as vectors. So now it is quite clear that the amplitude of the three waves are different. The second wave leads the first wave by a phase phi, and the third wave leads the first wave by a phase angle pi by 2. So if we treat them as simple vectors, then our diagram will look like this. I have already the diagram ready. So the first wave I have represented by a vector of length a naught, and I have drawn it horizontally. The second wave leads the first wave by an angle phi, which I have shown like this, and its amplitude is 3 root 2 a naught. So the length is represented by the amplitude 3 root 2 times a naught. The third wave, having an amplitude 4 a naught, is leading the first wave by an angle pi by 2. So the third vector I have drawn perpendicular to the first vector, starting from the second vector onwards, and the resultant of the three vectors is drawn by completing the polygon. So this represents the third vector. So we have completed a right angle triangle in which the base is the sum of a naught and 3 root 2 times a naught cos phi, and the perpendicular is 4 a naught plus 3 root 2 times a naught sin phi. So in the right angle triangle, if we write tan pi by 4, which will be 4 a naught plus 3 root 2 a naught sin phi divided by a naught plus 3 root 2 times a naught cos phi, and a naught is common, so we can take a naught common and cancel out in the numerator and denominator. Tan pi by 4 becomes 1, so this gives us 4 plus 3 root 2 sin phi divided by 1 plus 3 root 2 times cos phi, and if we further cross multiply and solve, we get 1 plus 3 root 2 times cos phi equal to 4 plus 3 root 2 times sin phi. So 3 root 2 times sin phi we bring in the left hand side, so we get 3 root 2 cos phi minus 3 root 2 sin phi as equal to 3. 3 gets cancelled, and if we divide by 2 on the both left hand side and right hand side, we get cos phi into 1 by root 2 minus sin phi into 1 by root 2 as equal to 1 by 2. And 1 by root 2, this 1 by root 2 can be written as cos pi by 4, and this root 2, 1 by root 2 we can write as sin pi by 4. So we can write it as cos of phi plus pi by 4 as equal to cos of pi by 3, and so phi we get as pi by 3 minus pi by 4, which on subtraction gives us pi by 12. So this is the answer to this problem. So this is a nice problem of waves, which becomes very easy if we treat the waves as simple vectors. I hope you get it.